So we're looking at a question that is a reagent in excess. Because when we read it, we've got information about the chemical reaction happening between hydrochloric acid and sodium hydroxide. And we're going to be able to work out the number of moles of each we've mixed. Now, if we want the resultant pH, if we'd mixed exactly the same number of moles of both, because we have a strong acid and a strong base, then the pH would be 7 because it's neutral. But these are all set up that one's going to be in excess, and it's the one that's in excess that we've got too much of that's going to lead to a resultant pH. So our procedure will be to work out the number of moles of each that we're starting with. So for hydrochloric acid, the moles of HCl that we're starting with will be concentration times the volume. The concentration is 0.12 times the volume of 75, but remembering to convert it into litres. Alright, so we've got 0.009 for the number of moles of HCl we're starting with. Similarly for the moles of the sodium hydroxide that we're starting with, will be concentration times the volume. Looking at the numbers given, the concentration 0.2 and a volume of 25 mils, but adjusting it to be into litres. And we've got a value of 0.005. Now, the equation is important at this stage, just to refresh our memories that it's 1 to 1. HCl plus sodium hydroxide gives sodium chloride plus water, and it is balanced as it's written, so it's a 1 to 1 ratio. So if we look at what we're starting with here, we've said we've got 0.009 of a mole of that one, and 0.005 of a mole of that one. We can see that we would be using up all of the sodium hydroxide, and we have some of the HCl left over. So that our moles of our HCl in excess would be the amount we started with minus the amount that can react. You can only react with the amount of sodium hydroxide we've got. So we've got an excess of 0.004 of a mole. Now, we've really done the hard yakka, but we need to get it in a form where we can find our pH. And pH is minus the log to base 10 of our hydrogen ion concentration. So we have to convert moles into concentration. So our concentration of HCl that's in excess would be equal to our number of moles divided by the volume. And there's another trick there, that the volume there needs to be, I'm going to put volume total, because that number of moles of excess HCl is now floating around in 75 plus 25. It's floating around in 100 mils. So we're going to divide that by that 100 mils. So the excess concentration of HCl will be the number of moles that we had in excess, divided by the total volume. So it's 100, but again adjusting it to be in litres. So that means we're, that's 1/10, so 1/10, so it's times by 10, 0.04 is that's moles per litre. So we're almost there. If our concentration of our molecule is 0.04, then our concentration of our hydrogen ion is the same, because every molecule breaks up to give one hydrogen ion, and we're almost there. Therefore, our pH is equal to minus the log to base 10 of our hydrogen ion concentration, so minus the log to base 10 of 0.04. And I get a value of 1.4. Thank you.